Right, so let's look at this 2025 exam paper. That's for January intake, and this is section B. So I have question 1, which is saying, part A, the maximum theoretical power of a wind turbine is given by the equation P is equal to K rho AV to the power N, where rho is the density of air, A is the area swept by the turbine blades, V is the speed of the air, and K is a constant with no units. What is the value of N? What is the value of N? So simply by looking at this particular question, you're going to tell to say we're looking at dimensional analysis. And whenever we're solving questions on dimensional analysis, we have to make sure to say we follow the principle of homogeneity, which states to say the dimensions on both sides of the equation must be equating to each other. So they've given us this equation to say P is equal to K. We have rho, we have A, V to the power N like this, where we have P as the power. We have the dimensionless constant here. We have rho, which is the density. We have area that is swept by the blade. Then we have velocity here, which is raised to the power N. Okay, so what are we going to do first? The first thing that we're supposed to do is establish the units, but most importantly, the dimensions of each of these particular physical quantities that have been given here. So we have power, which is looking like the most complicated one here. And using the basics, you don't have to start from the difficult sides of dimension analysis. You're going to understand that power is just basically work done over time taken. So if I say this is work divided by time, you understand that work is also equal to what? It's also equal to force multiplied by distance. This is it divided by time. Then if you use Newton's second law, you're going to notice to say the force or summation of forces is equal to mass multiplied by acceleration, which means where I have my force here, I'm going to exchange and put mass multiplied by acceleration. This multiplied by distance should give me over time like that, which means basically these are the initial or the primary dimensions for the primary physical quantities that are in power. So we have the dimensions for mass, which is capital M. We have the dimensions for acceleration, which is distance over time squared. So I have my LT or minus 2 like that, multiplied by distance, which is basically just length. And I'll divide everything by the dimensions of time, which is basically just T like that. All right, so if I take this T to my numerator to establish the overall dimensions of power, I'm going to have my M, L, T to the power minus 3 like that multiplied by L. This L multiplied by that L, I'm going to have the dimensions. It should be M, L squared, T to the power minus 3. All right, so these are the dimensions of power in simple terms. Then so this is power, or rather this one. We can rub everything else. Power is ml squared t to the power minus 3 like that. Then let's go to rho, which is density. And you know to say density is just equal to mass over volume. So you have your mass there with dimensions m over volume. Volume is measured in cubic meters, which means its dimensions are basically length to the power 3 like that. So the overall dimensions of density will be equal to ml to the power minus 3 like that. Then we have area, which is measured in meters squared as the units of measurement. So basically the dimensions for area will be length squared like that. Then what else? Then we have velocity itself, v, and you know the velocity is distance over time. So I have my lt to the power minus 1 like that. Then we have k, which is a dimensionless constant. So just say this is dimensionless like that. All right, then we're going to get these dimensions that we found here and plug them into our equation that we've gotten or that we've been given in this particular case. So basically, I'm going to say my ml squared t to the power minus 3 will be equal to, I'll discard the case. It's in dimension analysis. We only focus on units that have dimensions. So I'll start with rho ml power minus 3 multiplied by the dimensions for area, which is L to the power 2, and the dimensions for velocity, which is LT to the power minus 1, but these are raised to our n like that. All right, so we'll continue to say ml squared t to the power minus 3. This will be equal to ml to the power minus 3 multiplied by L to the power 2. And this will be multiplied to L to the power n. I'm now distributing the power n, and t to the power minus n, since there is negative 1 there. All right, like this. Then what else? I'm going to have my ml squared t to the power minus 3. This will be equal to, I only have one mass here, so I have mass m, then I have length to the power minus 3, length to the power 2, length to the power n. So when you're multiplying the same bases with different powers, you just add the powers. So basically, I'm going to have length to the power minus 3 plus 2 plus n. Then I have t to the power minus n like that. All right, so m l squared t to the power minus 3. This will be equal to, I have my m, then negative 3 plus 2. This will give me negative 1 plus n. So I have length, negative 1 plus n like that. Then I have t to the power minus n. All right, so when we reach this part now of dimension analysis, what do? We're trying to find the value of n. So we're going to compare the powers of each dimension on both sides, the right-hand side of our equation, but also the left-hand side of our equation. So I'll start with the ones that we're focusing on, which the first one is L. So if you look at L, you can see to say on the left-hand side, we have L to the power 2 being equal to, on the right-hand side, we have L to the power negative 1 plus n. So this will be negative 1 plus n like that. Then I can solve for n. So I'm basically just getting the negative 1 and taking it to the other side of my equation. I'm going to have 2 plus 1 being equal to n like that. That means my n is equal to 3. All right, if you want, you can still use the t, but we've already gotten the answer as to the value of n. But if you want, you can also use t, because you can see to say t. On the left-hand side, it has a power of minus 3, whilst on the right-hand side, it has the power of negative n. So just divide both sides by negative 1, even that side by negative 1, you're going to get your value of n to be equal to 3 as a number like that, meaning this equation to complete it will be equal to P being equal to K rho AV to the power 3. So that means this is our complete equation. And this is all about this particular question, which is dealing about, which is dealing with dimensional analysis. Let's move on to the next question. Next question is still on units and measurements, and it's saying write the full names of the following units. Write the full names of the following units. So of units, those are basically one of the simplest questions, because we described this when we we're talking about units and prefixes. So in this particular case, if you look at unit 1, we would say capital C is used to measure charge in coulombs, whilst this is the symbol for micro. This is mil for micro. So which means the full name for this particular unit is a micro. Capital C for coulomb, which is the unit of measurement for charge. Then we have the mu there, which is just basically used to represent micro. Then now we have G, A, capital G and capital G, capital A. We not say capital A is used to measure electric current, which is an ampere. Then we have capital G as a prefix, which is used to represent giga. So this is giga. So we're going to say this is the same as giga ampere. So these are the phonemes of these particular units that we've been given in this particular case. And the next question is saying a helicopter is stationary at a height of 1,500 meters above the ground. A helicopter which is stationary at a height of 1,500 meters above the ground. So the question is saying state the two conditions necessary for the helicopter to remain in equilibrium, or state the two conditions necessary for the helicopter to remain in equilibrium. So we are now just stating the conditions that are necessary for this particular helicopter to be in equilibrium. And this is a question that is basically coming from equilibrium forces. So we know the conditions that are required for a particular substance or an object to be in equilibrium. One of the first conditions is that all the forces that are acting on that particular object must be in equilibrium. So we can just say the first condition, the resultant force. The resultant force in both the axes, which means in both the vertical and horizontal, this is the horizontal axis, and the vertical axis must be zero. Which means if I'm looking at this object, in order for it to be at equilibrium, the forces in the x-axis should balance, whilst the forces in the y-axis should also balance. That means this particular object is not going to move in any certain directions, because this force that is here is having the same magnitude as that one that is there. They're just opposite in direction, whilst the same is also the case when it comes to the y-axis. You have this particular force which is similar to this particular force, so they're basically balancing each other. They're similar in magnitude, but just different in direction. So this is going to be the first condition. We're going to say the net force acting on the object must be equal to zero. Basically meaning the summation of forces should be equal to zero. While still, the second condition, we're going to focus on the rotation. We have to make sure that the helicopter is not rotating. And if the helicopter is not rotating, what are we dealing with? We're dealing with the moment now. We're dealing with torque on the helicopter, because that is what is going to cause the helicopter to start either spinning around, or can I say in any axis, of which practically most of the times it will be in the horizontal axis, but there's also some rotation that takes place in the y-axis when it comes to changing direction. So we are now talking about balancing the rotation of the helicopter, which in order for it to balance, that means the resultant moment. The resultant moment, or maybe we can say torque in other cases, at any point should be equal to zero. So the resultant moment at any point should be equal to zero. And when I say this, that means the clockwise moments should be equal to the anti-clockwise moments. That means this particular object is not going to rotate about its axis. It's not going to rotate about any axis, because the moments that are acting on it are actually balancing each other. We can move on to the next question now. Question D, which is saying, given that the system is in equilibrium, find the value of F and the alpha. Find the value of F and the alpha. So the value of F is this one. This is the F that they want us to calculate, and the angle from the positive y-axis, that is the alpha that they're talking about. So they've already told us to say this particular system is in equilibrium. And if it's in equilibrium, that means the net force is equal to zero. the net force in this particular case should be equal to 0. So to begin with, let's just finish our free body diagram. Let's just finish our free body diagram. So I'll resolve these forces, especially these two, since this one is already only in the y-axis, so this one is only in the x-axis. I'll focus on resolving these two that are existing in two axes. So I'll start with F itself. So it has a component in the y-axis here, and it also has a component in the x-axis. So I'll just make the component in the x-axis slightly taller than or slightly longer than the 3 Newton force, so that I'm able to differentiate. Then we'll look at the 4 Newton force. It also has a component here and another component there. So people draw these vectors in different ways. If some would just write it like this, if this was vector F, they would draw the components as Fx here, then Fy here. And when you draw it like this, you're going to easily interpret, because if we have our alpha here, you can tell to say the x component is adjacent to the alpha, so it's going to carry a cos. Whilst you can tell to say this y component here is opposite to the alpha. That means it should carry a sign, but it is the same even when you write it like this, because you just basically know to say this is the x component, which will be f cos alpha, or this one is the y component, which if drawn in this particular direction like this, it's going to be opposite to the alpha, hence it's going to carry a sign. So this will be F newtons sine alpha, like this. All right. The same would have been done here, but I've just drawn them like this. So that basically means our x component, which is pointing towards the negative x direction, is the one that is adjacent to the theta. So it should carry a negative, or it should carry a cosine. And since it's pointing towards the negative direction, it should be indicated with a negative. So here we're going to have a negative 4 cos 30 degrees. Then we have the y component, which is pointing towards the positive y direction, but is also opposite to the 30 that we've been given here. So it's going to carry a sign. So I'm going to have 4 sine 30 degrees here. So when you're using this method of resolving vectors or resolving your forces, always make sure to indicate the sign so that you don't get confused. If the component is pointing towards the negative direction of any axis, or you have to indicate the direction by putting either positive, or which if it's positive, we just leave it like this. And if it's negative, we have to indicate the negative. So these are pointing towards the positive. We'll leave them like that. Whilst if this one is the only one which is pointing towards the negative direction, we'll indicate the negative. If you look at this one, it is only existing in the y-axis and it is pointing towards the negative direction. So we should also take note of the negative that is going to be there. All right, so that is what we have. Now, what are we going to do? We're going to apply the equilibrium in each axis. So if you look at the axis, they've told us to say this is at equilibrium, which means the summation of forces in each and every axis should be equal to 0, like that. So let's start with the x-axis. In the x-axis, you can tell to say we have this force that is here, and we have that force that is there. We only have two forces in the x-axis, or we also have the 3 newtons that is here. So we have 3 forces. So what do we have? We have these that are pointing towards the positive. So I'll say by 3 with the x-axis. So I'll say 3 newtons plus F cos alpha minus 4 cos 30 degrees. This should be equal to 0, like that. All right. Of which we can simplify this further by finding the value of F cos 30 or 4 cos 30. Just 4 cos 30 is 3.46. So I have 3 plus F cos alpha minus 3.46. this should be equal to 0 like that. So that means F cos alpha should be equal to 3.46 minus 3. So that means F cos alpha should be equal to 0.46. This is in the x-axis. Let's go to the y-axis. So in the y-axis, what do we have? We have this force that is pointing towards the negative y direction. Then we have this force is pointing towards the positive y direction, and also that force that is pointing towards the positive y direction. So I'm going to have 4 sine 30 plus F sine alpha minus 6. This should be equal to 0 like that. Then we can find the value of 4 sine alpha. This is just giving me 2. So I have my 2 here plus F sine alpha minus 6. This should be equal to 0 like that. So if I take these 2 to the other side of my equation, I'll have positive 6 there minus 2. That means in the y-axis, F sine alpha is equal to 4. So this is what I have, the y-axis. So I have this in the x and this in the y. So now what do? We can divide this equation into that particular equation. So the y component divided by the x component. So I'll start by rubbing here. Rub here, and I'm going to have F sine alpha being equal to 4, and this divided by F cos alpha, which is equal to 0.46 like this. Okay, so the F and F can cancel out, and alpha divided by cos alpha, this is going to give us tan alpha being equal to, let me just divide 4 divided by 46, getting 8.7. 8.70 like this. And using this, we can now take the tan to the other side using arctan. Say alpha will be equal to the tan inverse of 8.70. I just punch this into my calculator. Get our alpha, which is the angle here. Equal to tan inverse of 8.61 8.6188. This is giving me 83.38. So alpha is equal to 83.38 degrees. So my alpha here is equal to 83.38 degrees. As simple as that. So I've calculated the value of alpha. Now let's calculate the value of F. And in order for us to calculate the value of F, we can use either of these equations that we've gotten here at the end. So for example, if I say F sine alpha is equal to 4, whereas I'm trying to calculate F, what am I going to do? I'm going to say this F sine alpha, of which alpha is it? 83.38, like that. This being equal to 4. F will be equal to 4 divided by sine 83.38, like this. All right, so my F, let me say 4 divided by sine 83.38. I'm getting F as being equal to 4.03. 4.03 newtons, like this. So that is the value of F, ladies and gentlemen. And using this particular method, we've found both the value of F and the value of alpha as required in the question. As simple as that. And that is the end of our part D. We can move on to the next question, which is question 2 in this particular case. And in question 2, they're saying define acceleration. Define acceleration. And we know by now to say when we talk about acceleration, that means there is a change in velocity. We have a certain initial velocity to a certain final velocity, the change in speed, of which I don't want to use speed because it's saying define deceleration actually. So when you're talking about deceleration, they're just talking about the change in velocity, the same way I was explaining. But what we're supposed to remember is in this particular case, if we are decelerating, that means you're talking about a negative acceleration. There is a change in velocity, but there is a negative change in velocity. So when we are talking about acceleration, we say it's the rate of change of velocity. Acceleration is the rate of change of velocity. And the change that we experience in acceleration is positive because you have a higher velocity or a higher final velocity and a lower initial velocity. Whilst when it comes to deceleration, the opposite is the case. We have a lower final velocity and a higher initial velocity. So in a nutshell, we can just say it's the decrease in velocity with respect to time. Decrease in velocity with respect to time. That is how we define deceleration. That is part A. Part B is saying a car is traveling along a straight road at a speed v. A car is traveling on a straight along a straight road at a speed v. A hazard suddenly appears in front of the car. In the time interval between the hazard appearing and the brakes on the car coming to operation, the car moves forward a distance of 29.3 meters. With the brakes applied, the front wheels of the car leave skid marks on the road that are 12.18 meters long as illustrated below. Okay. It is estimated that during this skid, the magnitude of the deceleration of the car is 0.9 meters per second squared, of which, since it's deceleration, this should be negative, since we are experiencing a negative change in velocity. So the deceleration of the car is 0.9 meters per second squared. Determine the speed v of the car before the brakes are applied. Determine the speed v the car before the brakes are applied. As simple as that. So in this particular case, they're talking about reaction distance, which means from the time he sees the hazard to him putting the brakes into action, there is some distance that is traveled. There is also the braking distance before the car finally comes to a stop, which is this 12.8 meters. And they also talked about what? About the uniform deceleration. The magnitude of deceleration of the car is this value that they've given us here. So what are we going to do? The important idea that you're supposed to get after reading this particular question is that the car continues moving at a constant speed before the brake comes into action. So there's a constant speed for these 29.3 meters that we have here. Then once the brakes are applied, the car also starts decelerating uniform. As simple as that. So what are we going to do in this particular case? We need to calculate our velocity. So let's solve it this way. We've been given the initial speed as v, which we don't know. This is our v initial. Then the final speed, of course, we know to say our v or maybe so I can say my initial, this would be my initial v is our initial velocity, then our final speed, final v, will be equal to 0 meters per second. So we're coming to a stop. The distance for the brakes to be applied, the displacement, or after the brakes are applied for it to come to a stop, is 12.8 meters there. And they've already given us the value of acceleration to say this is equal to what? This is equal to 0.9 meters per second, of which, since we know to say this is deceleration, we are always supposed to indicate a negative in front there. All right, so now we should just use an equation that is going to give us the initial velocity, given that we already have the final velocity, we have the displacement, and we also have the acceleration. The good equation that we can use is v squared being equal to u squared plus 2as. We have the displacement, we have the acceleration, we have 2, which is a constant here. We are looking for initial velocity. We already have final velocity. So this is what we are looking for. So we're going to say our 0 squared will be equal to u squared plus 2 acceleration, which is 0.9, multiplied by the displacement, which is 12.8, like this. All right, let me just punch this into my calculator. 0 here will be equal to u squared. This will be negative, multiplied by 0.9, multiplied by 12.8. This is giving me 23.04, so minus 23.04. I'll take the negative to the other side of my equation. That means my u squared will be equal to, it will become positive 23.04, like this. So I'm introducing a square root sign on both sides of my equation to get rid of this square here. That means my initial velocity will be equal to the square root of 23.04, which is equal to 4.8 meters per second. So our initial velocity is basically 4.8 meters per second. So this is the initial velocity before the brakes are applied. And that is the final answer on question B, as simple as that. Let's go to the next question, which is question C. And question C is saying a small metal ball is projected into the air with the velocity of 40 meters per second vertically upwards. So this is vertically upwards. The graph in the figure shows how the velocity changes with time until the ball reaches the maximum height. All right, until the ball reaches the maximum height. Use the graph to find this. So we're using the graph in this particular case. 1, the time at which the ball reaches its maximum height. All right, so one of the properties of free fall motion or projectile motion, in this particular case, if you throw something up, we understand to say that particular object goes against the acceleration due to gravity, which means it will be initially decelerating until it reaches its maximum height. And once it reaches its maximum height, what does it do? It just stops for a moment, which means at the maximum height, at maximum height, velocity is equal to 0 meters per second. So in order for us to determine where this ball reached its maximum height, we should look at it. At what point in time was the velocity 0 from the beginning here? So at this particular point was when the velocity was equal to 0. So what was the time here? You can say this is 1, 2, this is 3, and this is 4, 4.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 5. All right, so it's 4.1 seconds. So for part 1, the ball was at the maximum height at 4.1 seconds. Part 2, the deceleration of the ball. So we have to calculate the deceleration. How do you calculate deceleration? We know to say deceleration is equal to final velocity minus initial velocity divided by the time. So we want to calculate the deceleration, the time taken, which we can just say change in time here. So deceleration, this is for part 2, will be equal to the final velocity, which is 0, minus the initial velocity, which is 40, divided by the time, which is 4.1 seconds. This is going to give me negative 40 divided by 4.1. I'll just punch this in. Negative 40 divided by 4.1. Yeah, this is giving me 9.756. So 9.8. So deceleration was equal to 9.8 meters per second. This is negative. So you can tell to say the deceleration is just basically equal to what? It's equal to the acceleration due to gravity. That's why I said the force that is acting on this particular object. The acceleration that is acting at this particular object is the acceleration due to gravity. That's why I can say to say even the rate at which this ball is decelerating as it is going up is equal to the acceleration due to gravity, which is 9.8 meters per second squared. Okay, that is part 2. Part 3 is saying the maximum height reached by the ball. So we need to calculate the maximum height that is reached by the ball. And in order for us to calculate the maximum height, that is basically very simple because we know at the maximum height, the velocity of the ball is equal to 0 meters per second. Initially, when it was thrown vertically up, it was having a velocity of 40 meters per second, and this is taking a time of 4.8 seconds. 4.1 seconds rather, not 4.8 seconds. So in order for us to calculate the maximum height, we can just basically find the area under this velocity time graph, which is a triangle in this particular case. We can use the area under this graph, which is the triangle, to say the distance will be equal to half BH. So I'll say my half here multiplied by the breadth, which is from here up to there, that is 4.1 multiplied by the height, which is equal to 40. So half 0.5 multiplied by 4.1 by 40 is giving me 82. So the total height will be equal to 82 meters. So the maximum height traveled by this ball is basically equal to 82 meters. As simple as that. As simple as that. So there you have it, ladies and gentlemen. Or if you don't want to use this particular formula, you can also say, where am I going to write? Let me create some space here at the top. And just say v squared should be equal to u squared plus 2 s like this. All right, so what are we looking for? We're looking for the distance traveled. We know to say the final velocity is equal to 0. The initial velocity is equal to 40 squared plus 2. The acceleration is negative 9.8. Then we're looking for displacement. We can also use this formula. So we're going to find, let me just say 40 squared. 40 squared, this is 1,600. So 0 will be equal to 1,600 plus 9.8. So it should be negative since the acceleration is negative, so minus 19.6 displacement. So I'll get this guy and take it to the other side of my equation. I'll have 19.6 right by displacement. This will be equal to 1,600 like this. Divide both sides by 19.6, even that side by 19.6. That's going to cancel out. My displacement to be equal to 1,600 divided by 19.6, giving me 81.6. 81.6, which is the same as 82 meters. So it's as simple as that. So that is about part 3. Part 4 is saying on the figure, add a line to the graph to show how the velocity of the ball changes after it reaches its maximum height. Your line should extend to time 6 seconds. Your line should extend to time 6 seconds. So this is free fall. So once it reaches its maximum height, it's going to go down using this similar path that we had. So the ball is now starting to go downwards, and as it is going downwards, it is going to start gaining velocity, start to gain momentum. So velocity is now going to do what? It's going to become negative. Can I say negative? Because it's now going down. So if you are following the rules of the XY plane, the velocity will now start going towards the the negative y direction. That will be the direction of velocity, but it will be positive in such a manner that the change in velocity will become positive. We are now gaining velocity. We are increasing velocity as the ball is going down. So what are we going to do? We are supposed to draw a line reaching up to where the 6 seconds here to show how the velocity is going to do, how the velocity is going to increase in this particular case. And it's very simple because it's going to take the same path that we, or that you threw it with. So you can just say the velocity at 6 seconds is what we are trying to, or what we should calculate first so that we know where to end our graph. So we know to say at 4.1 seconds, the velocity will be equal to 0 meters per second. And this ball will now start doing what? Will start going down. So how will be the motion when going down? Let's calculate the final velocity on the time will be 6 seconds. So from the 4.1 to 6 seconds, you know to say we have a change in time, 6 minus 4.1, and this is going to give him 1.9 seconds. So there's a time of 1.9 seconds for it to reach 6.0 seconds like that. So I'll say my acceleration is equal to final velocity minus initial velocity divided by the time change. We know the acceleration. This is now moving along the direction of gravity. So I'll have my 9.8 being equal to the final velocity, which I don't know, v, minus the initial velocity, since it's coming from a stop, which is at the maximum height, 0, divided by the time, which is 1.9 seconds. All right. So I'll cross multiply this. Our final velocity v will be equal to 9.8 multiplied by 1.9. 9.8 multiplied by 1.9. This is giving me 18.62. 18.62 meters per second at 6 seconds. So if you look at 18, so this is okay, so I believe each box represents 2. So this will be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 here. So this is 18. So it will be in the middle of that box because 16.8. So it will be just somewhere inside this box. So I'll say my line will start from here, which is first It's going to start from here up to where 18.6 is, somewhere there. So that is where my graph is basically going to end, and that marks the end of part C. As simple as that. That is the end of question C. Let's move on to question 3. Question 3 is saying two blocks are attached by a massless rope, and the rope is placed over a frictionless pulley as seen in the image below. If the M1 block has a mass of 35 kilograms, so here I have 35 kilograms, and the M2 block has a mass of 25 kilograms, so it's 25 kilograms. Determine the acceleration and the tension in the system. All right, so as simple as that, the first thing you're supposed to do is draw your free body diagram. So I have this mass here and another mass there. Told me to say this is 35 kilograms, and you, using your logic, you can tell to say this system is going to accelerate in the direction of the larger mass. So which means the forces that are acting on mass 1 will be mg pointing down, then there will be tension in the string pointing up, then we have acceleration in that particular direction. Then on M2, we also have mg here, and tension in this in the rope, and we have acceleration pointing in that particular direction. So what are we going to say? We can say summation of forces on M1 will be equal to mass multiplied by acceleration. This is using Newton's second law. Summation of forces. What forces do we have? We have mg, which is pointing towards the direction of acceleration, which means it will be positive, and tension, which is pointing against the direction of acceleration, which means it will be negative in nature. So I'm going to say my mass multiplied by gravity, the mass is 35, multiplied by 9.8, minus tension should be equal to mass, which is 35, multiplied by acceleration, like that. What's the A? On M2, summation of forces on M2, this should also be equal to mass multiplied by acceleration. What do we have? We have mg, which is pointing against the direction of acceleration, meaning it will be negative. We also have tension, which is pointing towards the direction of acceleration, meaning it will be a positive force. So what am I going to do? I'll say my tension, which is positive, minus mg. What is the value of mg? It's 25 kilograms multiplied by 9.8, and this will be equal to 25 multiplied by acceleration, like that. All right. So 35 multiplied by 9.8, giving me 343. So I have 343 minus tension. This will be equal to 35A. Whilst here, this particular object, I have tension minus 25 by 9.8. This is giving me 245. 245. This will be equal to 25n. Right, so now we have two equations, this on M1 and this one on what? On M2. Both of our equations are missing tension and acceleration. Even here, we are missing tension and the acceleration, meaning we can solve them as a system of simultaneous equations. So I'll make T my substitute formula here. My T will be equal to 25A plus, if I take the 245 to the right hand side of my equation, I'm going to have a plus. So we'll have plus 245. Now get this value of t and plug it into this particular equation. So I'm going to have 343 minus, I'll open my brackets, I have 25a plus 245 like this, and this is equal to 35a. All right. 343 minus 25a minus 245. This will be equal to 35a, like that. Okay. Taking this negative to the other side of my equation, I have 35 plus 25. I have 35 plus 25. 35 plus 25. This is going to give me 60. So I'm going to have I can wrap at the top. So I don't have much space at the bottom. So I have 60 being equal to 343 minus 25a. 343 minus 25 or minus 245. Minus 245, this is giving me 98. So this will be equal to 98. You divide both sides by 60, even that side by 60. You're going to get your acceleration being equal to 98 divided by 60, which is 1.63. So this is 1.63 meters per second squared. That is the acceleration. Then when it comes to tension, you can get the same value of acceleration and plug it into our equation here. So say tension will be equal to 25.5a, which means I'm multiplying by 1.63 there plus 245. That means my tension will be equal to 25 multiplied by 1.63. 1.63 plus 5. This is giving me a value of tension. That's giving me a value of tension, which is equal to 286. 285.75, which is 286. So I can just say 286 newtons. That is the value of tension. As simple as that. So we've solved a lot of these questions, or a lot of such questions. By now, I don't expect an output machine to be a challenge to any of my students. So the acceleration, we said is equal to 1.63 meters per second squared, like that. Then the tension is 286 newtons, or 286 newtons. Let's move on to question B, and question B is saying a block weighing 10 newtons is on a ramp inclined at 30 degrees to the horizontal. A 3 Newton force of friction acts on the block as it is pulled up the ramp at a constant velocity. The force applied to pull the box up the ramp is or acts parallel to the incline. Part 1, determine the magnitude of the force applied. Determine the magnitude of the force applied. Right. So I have to find the value of the force applied here. Then we should find the coefficient of kinetic friction and the mass of the block. Okay. It's a very interesting question. A very, very simple question on inclined planes, because we looked at inclined questions a lot in our revisions. Looked at inclined questions a lot in our revisions. So I'll draw my free body diagram. This is my free body diagram. You understand that there is this block which is being pulled up. They've told us to say the weight of this particular block is 10 newtons. So we're going to have weight. Let me just draw it first. We're going to have weight pointing down there, but this is an inclined plane, inclined at 30 degrees, which means there's a coefficient, or rather there's a component of weight perpendicular to the surface. Then there's also another component of the weight parallel to the surface, like that. Then they've also told us to say there is a friction acting in the opposite direction to motion, then there's the force that is pulling here. Then since this is a surface, there will always be a normal force. Right, so this is what we have, a free body diagram. So this will be our weight, our 10 newtons. This is 30 degrees, meaning this is also 30 degrees. This will be, since this component is adjacent to the 30, it's going to be 10 cos 30 degrees. And here we're going to have 10 sine 30 degrees. Then we have friction. In fact, this is the 10 sine 30 up here. The one down is friction, since friction is on the surface. So say we have our friction here. Did they tell us the value of friction? It's a 3 Newton force of friction. All right, so I can just plug it in directly. This is a 3 Newton force of friction, and there's applied force, then there's the normal force there. Okay, so this is what we have. But I want us to find the magnitude of the force applied, which is this force that we have here. So in order for us to find this force, we're going to use Newton's first law. Say summation of forces, this one is in the x-axis, should be equal to, they've told us to say they are pulling it at a constant velocity, and if the velocity is constant, that means acceleration is 0, so which means the forces are balanced. So summation of forces in the x-axis should be equal to 0. What forces do we have? We have this force, which is acting along the direction of motion, so it's going to be positive, minus the forces that are opposing the direction of motion, which is the 3 Newton force, minus the 10 sine 30. The value of 10 sine 30 is 5. And this should be equal to 0. Negative 3 minus 8, this is my negative 8. So force will be equal to, this will be negative 8. If I take it to the other side of the equation, it will become 8 newtons. So that means the applied force is equal to 8 newtons. But 1, but B, the coefficient of kinetic friction. All right, so we know to say in order for us to calculate friction, we say friction is equal to the coefficient of friction, of which in this particular case it's a moving object, so it's kinetic friction multiplied by the normal force. And if you look at the normal force, it is balanced with the horizontal, or rather the perpendicular component of the weight. It is balanced with the component of the weight that is perpendicular to the surface. So that means the normal force is equal to 10 cos theta. Because if we say summation of forces and the y is equal to 0, that means the normal force should be equal to 10 cos 30 degrees. So that means my normal force here will be equal to, find the value of 10 cos 30. 10 cos 30 is 8.66. 8.66 newtons. So that is the normal force. So my frictional force, which they've already given me to be 3, will be equal to mu k multiplied by the normal force, which is 8.66. Divide both sides by 8.66, even that side by 8.66. This is going to cancel out. Therefore, my mu k, which is the coefficient of kinetic friction, will be equal to 3 divided by 8.66, which is giving me 0.346. 0.346. That is the coefficient of your kinetic friction. And part 3 is saying find the mass of the block. This is part 3. Find the mass of the block, and they've already given us the weight. Do not say weight is equal to mass multiplied by gravity. They've given us weight to be 10. This will be equal to mass multiplied by the value of gravity, which is 9.8. So I'll just divide both sides by 9.8, even that side by 9.8. This is going to cancel out. That means my mass will be equal to 10 divided by 9.8, giving me 1.02 kilograms. 1.02 kilograms. 1.02 kilograms. And that marks the end of this particular question. That marks the end of this particular question. We can look at the next question, which is question 4. Now, since we are starting a new question, I think we should pause a little bit on this particular video so that we continue it in our next video. So which means if you want to see the full solutions to this particular paper, you have to watch our next video, which will have question 4, 5, but also 6. So thank you very much for watching this particular video. Don't forget to subscribe to the channel, share this particular video, like, but also leave a comment. Don't remember, if you want, or rather, don't forget, if you want the full solutions to this exam paper, including section A and the remaining other questions and the test papers, the quiz papers, just to prepare for final exams, you should register with us at discretelearning.com or download our app from Google Play Store. It's just at a very fair price. You'll find the procedures to registering in the description of this particular video. Thank you very much for watching. Until next time, stay blessed.